Welcome my beloved scholars, welcome back to the channel. Today we're looking at comparing fractions, this time with different denominators. We have already done a video comparing fractions that had like denominators, same denominators. So if you don't yet know how to do that, you can go and watch that video. Today we're focusing on the fractions that have different denominators. So that means the numbers down the bottom are different. So we can't just compare the numerators as we did when the numbers at the bottom, the denominators were the same. We can't just compare the numerators. This time we actually have to do an additional step. To compare fractions with different denominators, you must first give them the same denominator. So you remember how easy it was for those who watched that video? Do you remember how easy it was to compare the fractions once they had the same denominator? It was pretty easy. So we need to get these fractions to the point where they have the same denominator, and then we can compare them. How do we make them have the same denominator? Well, we have to find the least common denominator. I also did a video on that for those who don't know how to do that. So there are different methods of doing it. The method I'm going to show you is actually to find the least common multiple so we can compare them. Alright, so we focus on the denominators and we say, what's the smallest number that 8 and 4 can go into at the same time? It's always wise to look at one of the numbers to see if they are the least common denominator. In other words, start with the bigger number and see if the smaller one can go into it. Because if the smaller one can go into it, the bigger one is the least common denominator or the least common multiple. So since 4 can go into 8, then 8 is the LCM. So now we need to see how do we change the numerators based on this new denominator. So what we do is we divide the LCM by the denominator, and the result that we get, we multiply the numerator by that. So 8 goes into 8 one time. 6 times 1 is 6. 4 goes into 8 two times. 1 times 2, 2. So now both these fractions have a common denominator of 8. Now we can go ahead and compare the numerators to see which one is bigger. So actually 6 is bigger than 2. So 6/8 is bigger than a quarter. So we put the greater than sign for that one. So the first step was to make sure that they have the common denominator or the common multiple. When we put them over the common denominator, then we can go ahead and compare the numerator. So let's do that for the 7 and the 5. The LCM of 7 and 5. What's the smallest number that 7 can go into and 5 can also go into? I did a video on how to find the least common multiple. You can check that video if you're not yet familiar with how to find it. But we're just thinking about the smallest number that both of these can go into. In this case, that's 35. 7 goes into 35 5 times. 3 times 5, 15. 5 goes into 35 7 times. 2 times 7, 14. So what we have done, really, we have created equivalent fractions that have the same denominator we can compare. So an equivalent fraction for 3/7 is 15 over 35. An equivalent fraction for 2/5 is 14 over 35. And now we can compare the two. 15 is bigger than 14. 3/7 is bigger than 2/5. See that? So it's pretty easy from the point of getting them to the same common denominator. We just compare the numerators at that point. So what's the smallest number that 3 and 10 can go into? What's the LCM of 3 and 10? That would be 30. So now we're going to create equivalent fractions for 1/3 and 4/10, so we can have the same denominator, so we can compare the numerators. 3 goes into 30 10 times. 1 times 10 is 10. 10 goes into 30 3 times. 4 times 3, 12. So now that we have the equivalent fractions, 1/3 is an equivalent fraction for 10/30. 4/10 is an equivalent fraction for 12/30. So these two are what we're comparing because they are the ones with the same denominator. This is the same fraction as this. They are equivalent. Right? So 10 is less than 12. Therefore 1/3 is less than 4/10. We have 9/16 and 2/8. Alright, so 8 can go into 16. Like I said, always start by looking at the bigger number to see if the smaller one can go into it, is a factor of it, and that will indicate that the bigger one is the LCM. So 16 is the LCM because 8 can go into 16. 16 goes into itself once. 9 times 1, 9. 8 goes into 16 2 times. 2 times 2, 4. So we have just created equivalent fractions. 9/16 is an equivalent fraction for itself. 9/16. 4/16 is an equivalent fraction for 2/8. Now we can compare these two now that they have the same denominator. 9 is bigger than 4. So 9/16 is greater than 2/8. Are you following? So what we're doing, again, we're giving them the same denominator, common denominator, so we can compare the numerators. We can't go ahead and compare the numerators yet because they are not balanced. They have different denominators. Right? So we must get them over the same denominator before we can compare. So the LCM of 11 and 4, the smallest number that 11 can go into and 4 can go into, will be 44. 11 goes into 44 4 times. 5 times 4 gives 20. 4 goes into 44 11 times. 1 times 11 is 11. So we have created equivalent fractions. 20 over 44 is an equivalent fraction for 5/11. 11 over 44 is an equivalent fraction for a quarter. So now that these two equivalent fractions now have the same denominator, we can compare. 20 is greater than 11. So 5/11 is greater than a quarter. Alright, so 10 and 5, we're comparing these two, finding the LCM for 10 and 5. Remember, 5 can go into 10, therefore 10 is the lowest common multiple, least common multiple. 10 goes into 10 once. 6 times 1 gives 6. 5 goes into 10 twice, 2 times. 2 times 2 gives 4. 6/10 is an equivalent fraction of itself, 6/10. 4/10 is an equivalent fraction of 2/5. These two fractions have the same denominator, so we can compare the numerators to see which is the bigger. 6 is bigger than 4, therefore 6/10 is greater than 2/5. Alright, so we have these two to go. We're finding the LCM for 7 and 3. The smallest number that 7 can go into and 3 can also go into will be 21. 7 goes into 21 3 times. 4 3 is 12. 3 goes into 21 7 times. 1 times 7 is 7. Alright, so we have just created two equivalent fractions. 12 over 21 is an equivalent fraction of 4 over 7. 7 over 21 is an equivalent fraction of 1/3. So now that these two fractions have the same denominator, we can compare the numerator to see which is the bigger. 12 is clearly bigger than 7. Therefore, 4/7 is a bigger fraction than 1/3. Let's look at 10 and 15. Can you think of the smallest number that 10 and 15 can go into? Well, that number is 30. So we put the 30 there. We're going to create some equivalent fractions now. 10 goes into 33 times. 9 3 is 27. 15 goes into 32 times. 14 times 2, 28. So actually this is the bigger one. 28 is bigger than 27. 27 over 30 is an equivalent fraction for 9, 10. 28 over 30 is an equivalent fraction for 14 over 15. 28 is bigger than 27, so we put the less than sign. 27 is less than 28. So we put it up here. 9/10 is less than 14 over 15. Now, don't do what some students do when they're asked to compare fractions. What some students do, they just look at the numbers and they say, you know what? The 7 looks bigger than the 5, or in this case, let me see one of them that has the less than sign. Alright, so they just look at the actual number, and they'll say 10 is bigger than 5, 11 is bigger than 4, or 15 is bigger than 10, and they use that as the basis for comparing. Sometimes you might end up being right. However, there are times when you're going to be wrong. So you have to actually make sure you put them over the same denominator before you compare them. Alright? So let's see if we can do some examples of those kinds. Alright, so let's say we have 1/7, 3/4. Let's look at these three comparisons. Alright. Now, some children will look and they'll say, okay, so we need to compare these fractions. They're looking at the 7 and they're saying, but 7 is the biggest one on the board right here, right? 7 is the biggest one of those 4 digits that they're looking at. So this must be the bigger fraction. Let's see if it is. The LCM of 7 and 4 would be 28. 7 goes into 28 4 times. 1 times 4 is 4. 4 goes into 28 7 times. 3 times 7 would be 21. 4 over 28 is an equivalent fraction of 1/7. And 21 over 28 is an equivalent fraction of 3/4. But which of the two fractions is the bigger? 21 is bigger than 4. That means 1/7 is the lesser fraction. 1/7 is less than 3/4. So if you had just looked at the 7 and said, but 7 is bigger than 4, so that must be the bigger one, so you would be wrong. You actually have to put them over the same denominator before you can compare. When you're dealing with fractions, you can't just look and say, oh, this one looks bigger, because it has a bigger number somewhere in it. Let's check these two. Now we have 2/9 and 5/6. Just looking at them, the 9 is popping out at you, you're saying, but the 9 is the biggest one out of the 4. Therefore, 2/9 must be the bigger fraction. Let's see if it is. The smallest number that 9 and 6 can go into is 18. 9 goes into 18 2 times. 2 2s are 4. 6 goes into 18 3 times. 5 3s are 15. So 4/18 is an equivalent fraction of 2/9. 15 over 18 is an equivalent fraction of 5/6. When we compare the 4 and the 15, we see that 4 is the smaller of the two. So 2/9 is actually a smaller amount than 5/6. So in other words, if we had two pies of the same size, right? And we cut one into 9 pieces and took out 2 pieces, and we cut one into 6 pieces and took out 5, the one that you cut into 6 and took out 5 pieces, you would get more if you got those 5 pieces than if you only got 2 pieces out of the one that was cut up into 9. That's really what it's saying, right? So don't just look and say, oh, this number looks big. Actually, for many fractions, the bigger the denominator, and if the numerator is pretty small, that's an indication that that's a tiny fraction you're dealing with. So be very careful. Let's look at this one. So we have 12 and 20. What's the smallest number that 12 and 20 can go into? That would be 60. So 12 goes into 65 times. 8 5s are 40. 20 goes into 63 times. 2 3s are 6. Alright. So comparing them, we see 40 over 60 is an equivalent fraction for 8 over 12. 6 over 60 is an equivalent fraction for 2 over 20. Comparing the numerators, we see that this is the bigger fraction. So those who had looked at the 20 and say, oh my, 20 looks so big, that one must be the bigger one, you would be wrong. You really have to check. You really have to put them over. You have to level the field, in other words. You have to level the playing field. Everybody starts from the same place. That's what we're really doing when we're finding the least common multiple. We're saying everybody is getting this amount, and take out the equivalent of what, from this amount, the equivalent of what that would be. Or the equivalent of what this numerator would be. That's what we're doing. Then we can really compare them. So we see that this is actually the bigger fraction. 8/12 is a bigger fraction than 2/20. Again, if you got two things, you cut up one into 20 parts and just took out two pieces. They're already small parts because you're cutting it up into 20. So each part is already small, and then you're only taking out 2 of those parts. Then if you had cut it up into 12, each piece would be bigger already, and then you're taking out 8. So this is the bigger amount in all, right? So remember, to compare fractions with different denominators, we must, let me underline must, first give them the same denominator. Only then can we go and compare to see which is the bigger. And it doesn't have to be 2, it could be 3, 4 different fractions you get to compare. Line them out the same way, find the LCM, and compare the numerators. And you might be asked to put them in ascending order or descending order, which we have videos on those. We have videos on everything. So if you have benefited from this video, please drop a comment to say thank you, miss, and share the video so others can benefit as well. If you have not yet subscribed, please subscribe, and I'll see you in the next video.